Welcome to the deep dive. You sent us the sources, the research, the architectural blueprints, the governance models, and we distill it all down to the essential insights you need to navigate the cutting edge of enterprise technology. Today, we are deep diving into one of the most fundamental architectural shifts happening right now. It's one that really defines the future of work within large organizations, the rise of autonomous systems. We are moving well past the era of AI as just, a simple chat feature or some narrow classification algorithm. Instead, we're looking at how autonomous reasoning-based systems are becoming the core shared nervous system of the modern enterprise. Okay, let's unpack this. Our mission today is highly specific and I think absolutely critical for anyone involved in enterprise architecture or product development. We are exploring exactly why organizations have to stop treating these autonomous systems as isolated, siloed applications. Instead, start managing them as a unified, shared, governed execution substrate. We are looking at the foundational work required to architecturally manage an intelligent workforce, one that spans every single domain across the entire company.
And that phrase, intelligent workforce, is, I think, the perfect way to frame the sheer scale of this transition. I mean, for decades, organizations have built computational systems that just execute predefined deterministic instructions, code. Now, we are introducing systems that perceive, reason, plan, and then execute actions in the real world with a degree of non-determinism. This is a fundamental change in the computational paradigm of the modern organization. It's huge. The move from code execution to reasoning execution demands a completely new approach to infrastructure, to security, and especially to governance. If you don't build the right foundation now, the operational risk it'll quickly become unmanageable.
Okay, let's start with history then, because understanding where we came from explains this massive operational hole many organizations are currently falling into. Where did intelligence traditionally live inside the enterprise, and what was that foundational assumption?
Well, historically, intelligence was always deployed as what we define as a feature.
Hmm.
Think of it as a specific, narrow capability embedded deeply within a larger, self-contained software suite. If you had intelligence, it was an add-on. A small deterministic algorithm for, say, autocomplete suggestions in an email client, or a simple algorithm for classifying customer tickets.
So it was just a small, localized module, tightly coupled to one application.
Exactly. And if it failed, the impact was contained. It was an annoyance, but it was contained within that single user interface.
So why does that application-centric approach suddenly become this massive, almost existential risk when we introduce modern autonomous agents? Agents that can plan and sequence and execute complex actions across multiple systems.
Because the nature of the risk has fundamentally changed. When you have an agent that can interact with the financial system and the inventory system and the CRM all in one reasoning cycle, well, siloed applications create systemic operational risks that scale exponentially. If every business unit is independently building its own autonomous agent, even if they're all using the same large language model, you instantly get fragmented governance, completely inconsistent reasoning, and just tremendous cost duplication.
So you can't manage safety or costs, not really, not across the enterprise.
Not effectively, no. You're just flying blind.
It sounds like the key concept here, according to the sources, is one of standardization and ubiquity. That to achieve real agentic scale and resilience, enterprises have to treat these systems with the same level of architectural commitment as, say, their centralized database clusters. It has to become core infrastructure.
That's the critical unlock.
Yeah.
When you standardize the environment where agents perceive, reason, and act, what we're calling the execution substrate, you gain centralization over all the important control points. Costs, safety policies, security protocols, data privacy enforcement, all of it. This control allows you to safely decentralize the actual execution of business logic across dozens or hundreds of different product teams.
But without that standardized substrate,
Without it, you are just launching uncontrolled smart software into your mission-critical systems. It's chaos.
okay, to really drive home why this infrastructure approach is non-negotiable, why it's a security and compliance mandate, not just an IT preference, we need to look at the increasing impact of failure. Our sources break this down into 3 distinct tiers of intelligence. Can you detail that spectrum for us?
Yeah.
And maybe focus on how the potential blast radius changes with each tier?
Of course, it's a crucial distinction. We start, as we just discussed,
Yeah.
with feature-level AI. This is intelligence that is narrow, localized, and highly deterministic.
So like tagging an email.
Exactly. If the classification model fails to tag an email correctly, the impact is minimal. It's annoying, sure, but the failure is contained entirely within a single application component.
Okay, then we move up in complexity. Maybe AI starts executing small internal workflows. That would be product-level AI.
Correct. This tier involves goal-oriented execution for specific, well-defined workflows. Typically, this crosses a small, contained set of internal APIs within a single product group. For instance, an intelligent system managing the returns process for one retail channel.
And the failure impact there.
It's moderate. It disrupts a specific business process. It might affect a customer segment. It requires manual intervention. But the fallout is generally contained within that one product area. You might have angry customers, but your core financials are probably safe.
And then we hit the threshold, the one that demands a complete architectural overhaul. Infrastructure-level agentic systems. This is our focus today.
This is where non-determinism meets mission criticality. These systems are defined by autonomous, multi-domain reasoning, planning, and real-world action execution. Because they're shared across the entire enterprise, interacting with multiple systems of record. The failure impact is severe.
We are no longer talking about a contained error.
No. We're talking about a global blast radius impacting core operations, regulatory compliance, and the company's financial integrity. Imagine an agent erroneously issuing mass refunds or transferring production code without authorization. That severity demands that intelligence be treated as core infrastructure.
That severity, that difference between a feature failure and an infrastructure failure is why we have to prevent the chaos the sources called shadow AI. Here's where it gets really interesting. This isn't just about unsanctioned software. This is about reasoning sprawl.
That's exactly right. Shadow AI is the dangerous consequence of that architectural fragmentation. It's when product teams embed autonomous capabilities without any centralized oversight, leading to this sprawling, ungoverned landscape of unique reasoning loops.
It sounds like the early days of cloud adoption, but way more dangerous.
It's a great analogy. Every team spinning up their own instances without standardization. But now those instances are capable of making independent business decisions.
So the cost is one thing, but the risk profile for a large organization is arguably much, much worse. What are the specific failure modes that come from this fragmentation?
Okay, there are three critical, predictable risks. First, and simplest to understand, is fragmentation and redundancy. If every engineering team is independently building, configuring, and maintaining foundational solutions for identity, for rate limiting, for context management, they are just driving up the total cost of ownership and technical debt dramatically.
Solving the same 10 problems over and over again, and probably not very well.
Exactly, instead of leveraging a single, robust platform solution.
Okay, the second is the governance nightmare you mentioned, cross-domain coupling.
This is the failure mode that keeps security and compliance teams up at night. This is when an agent designed for a very specific low-risk area, say, marketing automation inadvertently triggers a high-risk action in a completely separate domain, like the finance ledger. Because the agent's logic is siloed within that marketing team's app, there is no centralized architectural awareness of the downstream impact.
And you get this massive, uncontained blast radius.
A huge blast radius, violating the principle of least surprise in the worst possible way.
And the third risk, this one undermines the very trust in the system. Inconsistent reasoning.
Yes, and this is often caused by divergent grounding techniques and something called ontology drift.
Ontology, that's basically the shared vocabulary of the enterprise, right? The definition of truth.
Precisely. And if different agents are trained or prompted with subtly different definitions for key business entities, say what a customer is, they will offer completely contradictory solutions when interacting with the same user. If a customer is told two different things by two different intelligent parts of your system within minutes, the operational integrity of the whole organization just collapses. Trust is destroyed.
And that instability is the clearest case for treating intelligence as a shared, centrally governed service.
It has to be. It can't be just a siloed application feature anymore.
So if the old application-centric model is a clear recipe for chaos, the solution is defining a new architectural foundation. The sources detail a set of doctrine-level principles that must form an enforceable contract between the central platform team and all the product teams using the agents.
And these principles are non-negotiable. They have to prioritize long-term safety, auditability, and sustainability over, localized short-term deployment speed. They define the rules of engagement for every single agent.
Okay, let's start with the first one, which addresses fragility. Separation of product logic from agent logic.
Right.
Wait, can we break that down? It means you must physically and logically decouple the how from the what, the mechanism of achieving a goal from the business intent itself. Why is that so critical?
It's all about agility and resilience. If the reasoning logic is baked directly into the product team's microservice code, say, the code managing a return processing flow, the system becomes incredibly brittle. The enterprise loses the ability to swap out the underlying foundational models or update a global PII masking policy without requiring every single product team to rewrite and redeploy their application code.
Which creates unacceptable friction. And the common failure we see here is the creation of what the sources call prompt monoliths.
Exactly. These prompt monoliths are services where teams have embedded complex, multi-step reasoning prompts directly into their application logic. This makes them exceptionally hard to audit, impossible to update centrally, and tightly coupled to a single model version.
So how does the platform enforce this separation?
It uses a formal task definition schema. Product teams only provide the high-level goal, like process customer refund, and the approved tool specifications. The platform runtime then manages the complex, dynamic reasoning loop and context injection on their behalf.
Okay, let's move to the second principle, which balances efficiency with security. Reusability without loss of control. We want agents to be modular and reusable, but we absolutely cannot let that compromise security.
The primary violation risk here, and it is rampant, is privilege escalation. Teams try to share agents by exposing overly permissive API keys, or worse, allowing the calling agent to just inherit all the permissions of the tool it is calling.
So a low-risk agent suddenly gets admin privileges because it called a shared utility.
Precisely. A low-risk agent processing a small transaction suddenly has enterprise-wide access. It's a disaster waiting to happen.
So how does the architectural enforcement fix this dangerous inheritance problem?
The platform enforces security through a robust identity propagation model. This ensures that the shared agent, no matter its own configuration, executes strictly within the security context of the original initiator, the user who kicked off the cycle. And crucially, the platform reevaluates permissions at every single tool invocation, not just once at the beginning.
Mid-flight.
Mid-flight. So if the agent tries to call a high-risk tool, the identity layer checks if the original user is authorized right then and there.
Principle number 3 addresses that classic organizational tension. Centralized guardrails with decentralized innovation. How do you give teams freedom to innovate while maintaining a non-negotiable safety envelope?
This is a policy problem solved with architecture. The platform has to define the absolute non-negotiable policies. Things like PII masking rules, maximum financial transaction limits, content policies. Product teams need freedom, but safety must be uniform and non-bypassable, relying on dozens of developers to manually include the same safety checks as a guaranteed pass to human error.
And the mechanism for enforcement is the Agentic gateway. This is the single choke point.
Precisely. The Agentic gateway is mandatory. It's the final safety net. It intercepts every outbound action requested by an agent before that action is allowed to touch any system of record. If the action violates a global policy, say, a refund of $10,000 when the limit is $1,000, the gateway blocks it, logs it, and notifies a human, all before the financial system even sees the request.
Principle 4 is about resource fairness and data protection. Clear blast radius boundaries. We have to prevent the noisy neighbor problem.
The noisy neighbor problem is an inevitability in shared infrastructure. It occurs when one business unit's poorly configured agent consumes all the organization's shared reasoning capacity, exhausting the token quota, or tries to access data belonging to another unit.
And this usually comes from sharing admin credentials or quotas, doesn't it?
Almost always. Overly permissive access given to all agents.
So how do we architecturally draw those strict boundary lines?
Through two mechanisms. First, resource flows, which strictly limit the computational consumption, the token usage, for any given agent. Second, and critical for security, data tethers. These are architectural mechanisms that strictly limit the informational reach of an agent based on its assigned domain. It's like putting an invisible leash on the agent, binding it only to the data it's authorized to see.
Okay, finally, principle 5. Backward compatible evolution. The foundational models and reasoning engines are changing constantly.
That's the core challenge. The underlying models change constantly, sometimes dramatically. The infrastructure has to accommodate these major upgrades, a complete model swap, even without requiring every existing business workflow to break.
The major violation here being tightly coupling your prompts to a specific engine version.
Exactly. If the platform upgrades the engine, your entire agent ecosystem could be paralyzed.
So the platform absorbs that complexity. How is that enforced?
Architectural enforcement relies on the model abstraction layer. This crucial layer normalizes the inputs and outputs. It standardizes the interaction. This allows the platform team to rotate engine switching providers or upgrading versions via simple configuration updates. Because the product code only interacts with the abstraction layer, no product code changes are necessary.
That structural decoupling sounds like the only way to survive the rapid innovation cycle we're in.
It is. You want innovation at the model layer, but stability at the application layer. The abstraction layer is the firewall against that instability.
With those principles locked in, we can now visualize the blueprint, the reference architecture itself. This isn't just a list of services, it's a foundational substrate where intelligence is a dedicated, governed service provided by the platform.
This is the operational engine that translates the principles into reality. This multi-layered substrate abstracts away the complexities of reasoning and secure execution, allowing developers to focus purely on business outcomes.
Okay, let's walk through the 7 essential layers, starting with the heart of it all. Layer 1, agent runtime layer. This is the engine room, right?
It is the execution crucible. This is where the agent's reasoning loop happens. It manages the core cycle. Perception, getting input, reasoning, planning steps, and action, executing the plan. This layer is also responsible for maintaining short-term memory, which is the session state necessary for the agent to maintain context through a complex task.
So it doesn't forget what happened 3 steps ago.
Exactly.
Moving up, we get to multi-agent complexity. That's where layer 2, orchestration and workflow services comes in.
Yes, this layer manages multi-agent collaboration. It functions as the high-level dispatcher or supervisor. It takes a large, complex, goal-like process and insurance claim and breaks it down into subtasks. Verify policy, calculate valuation, submit payment. It then routes those subtasks to specialized agents, all while preserving the full context during the handoff.
Next, the critical security choke point, layer 3, tool and action gateway.
This is the single, non-negotiable passage point for all agent interactions with external enterprise systems, databases, CRMs, you name it. It performs 2 key functions. First, translating the agent's natural language intent into structured API calls, and second, enforcing the initial layer of authentication and logging.
And immediately layered on top of that is the mechanism that ensures safety. Layer 4, policy, safety, and cost enforcement.
This is the service that ensures compliance and financial oversight. It is non-bypassable because it sits between the runtime and the action gateway. It evaluates every proposed agent action against the central policy library.
So it enforces the maximum refund limit.
And content policy violations. Critically, it also tracks real-time resource spend, allocating costs against business unit quotas.
Security is paramount. Agents are new employees, so they need identities. That brings us to layer 5, identity and authorization layer.
Treating agents as first-class identities is the foundation of the zero-trust model for these systems. This layer manages the full life cycle of agent credentials, assigns unique identity tokens, and enforces the principle of least privilege.
Bare minimum access required for the current task. No more.
Exactly. No more generalized service accounts.
Then comes the system for when things go wrong. Layer 6, observability and audit plane.
This is the forensic backbone, the black box recording. It doesn't just collect application logs. It collects reasoning traces and detailed metrics. This is essential for post-incident analysis.
So you can see why an agent made a specific decision.
Right, and it's vital for meeting regulatory reporting requirements.
And finally, the layer that makes the whole system reusable for developers. Layer 7, developer enablement and publishing layer.
This provides the centralized agent registry. This is where product teams publish their agent definitions, their capability descriptors, and tool specs, making them discoverable and reusable by other teams. It democratizes the consumption of agentic capabilities.
What's fascinating here is how these layers actually interact. There are 2 key interactions described. Let's start with interaction A, the setup phase, where a product team introduces a new agent.
The product team doesn't deploy code. They publish a manifest defining the agent's intent and the tools it can use. The platform receives this manifest, validates it against the overarching domain policy, and only if it complies, issues a unique, revocable agent identity via Layer 5.
So the agent gets his digital passport.
That's right, with clear boundaries from day one.
And interaction B, the moment of action, where the rubber meets the road.
When the agent reasons it needs to call a tool, say, to update a customer record, it sends the request to the action gateway. The gateway immediately pauses the request mid-flight. It then consults the policy engine in Layer 4 for an allow-any decision. It logs the intent for the Layer 6 audit trail, and only then securely fetches the necessary credentials from the identity layer to execute the call.
That mid-flight policy check is the foundation of safety.
It is. It ensures no action can ever bypass the central safety controls, regardless of the prompt the agent received. The agent can reason all it wants, but its ability to affect the real world is constantly mediated and guarded.
It's like a corporate babysitter with full, non-bypassable veto power.
Exactly. The intelligence is decentralized, but the governance and enforcement remain strictly centralized.
The architecture sets the rules, but governance relies on clear human accountability. We establish the relationship between the platform team and the product teams as a technical contract. Let's clarify exactly where those ownership lines are drawn.
Clear boundary definition is critical. The platform team must own all core infrastructure. This means selection and rotation of reasoning engines, the definition of global safety policies, the identity infrastructure, the audit infrastructure, and critically, the kill switch to pause all activity in an emergency. They own the SLA for the substrate.
And the product team's role is more focused on business performance.
Yes, they own the specific operational aspects. This includes prompt engineering, domain-specific grounding, teaching the agent their business unit's language monitoring performance against business KPIs, and mapping their data models to the agent's tools. They own the business outcome.
Okay, let's nail down that critical governance boundary. What are the two non-negotiable things product teams must never be allowed to touch?
First, they must never handle raw credentials. All secrets are mediated exclusively by the platform's identity layer. Second, and this is where most organizations fail, they must never have the ability to bypass a global guardrail.
Like a BII filter or transaction limit.
Exactly. If they can bypass global policy for testing or convenience, the entire architectural safety model collapses immediately.
Moving to agent reuse and versioning, we talked about the agent registry. Why does reuse without strict governance increase the risk of what the sources call logic contagion?
Logic contagion is the nightmare scenario where a minor change in one reusable component, a common utility agent, cascades into a catastrophic failure in a completely different, high-value domain that relied on it. This happens when the underlying reasoning is updated without proper semantic versioning.
So the agent registry needs to provide rich metadata so consumers can assess the risk before they integrate. What kind of metrics?
Beyond simple documentation, it needs trust metrics, like historical accuracy rates and quantifiable hallucination scores. And critically, it must publish the resource footprint, the average token cost and latency. This allows developers to make informed risk and cost decisions.
And to prevent those logic contagion failures, the sources prescribe a strict versioning model, the deprecation pipeline. How does that work?
This pipeline imposes structural stability. You have the stable version, currently trusted. Beta is the latest for testing. When a version is retiring, it moves to deprecated, which automatically notifies all downstream callers. And finally, sunset means the version is completely deactivated. This prevents a chaotic spaghetti of agent dependencies.
Now let's tackle interoperability and collaboration. As the intelligent workforce matures, processes will span multiple agents owned by different business units.
Yes, a claims agent in finance might need to call a vehicle valuation agent in underwriting.
So we need standardized communication between them.
We need agent-to-agent A2A protocols. These are standardized message formats that allow agents to discover each other's capabilities and negotiate task delegation at runtime.
Yeah, and when Agent A calls Agent B, we still need full auditability across the entire path.
That's where the context envelope comes in. When Agent A calls Agent B, the platform wraps the request with three things: the original user security token, the primary business intent, and a crucial trace ID. This trace ID allows the art of playing to provide end-to-end traceability.
Finally, let's talk about data mediation and isolation. We're moving past simple role-based access control to context-aware data mediation.
It is absolutely critical. The architecture must strictly distinguish between two types of data: global grounding, data shared, safe knowledge like HR policies, and siloed operational data, highly sensitive info like payroll records or customer health data that must never cross domain boundaries.
How does the platform enforce that isolation against an agent that's actively retrieving information?
The data mediation layer acts as the dynamic gatekeeper. There are two key methods. First, logical isolation. When an agent queries a database, the mediator layer automatically and non-bypassably appends a tenanted or domained filter to the query.
That's fascinating. The agent thinks it's querying the whole database, but it isn't.
Exactly, it's conceptually walled off.
And the second, stricter method for the most sensitive information.
That's physical isolation. High-risk agents, those in Zone 1, must operate in dedicated, separate compute clusters. They have no physical network path whatsoever to other domains' sensitive data. This is the ultimate safety measure.
And that audit trail you mentioned, it does more than just compliance, right?
It's vital for system improvement. The platform records not just the data was accessed, but how it was used in the agent's reasoning loop. If an agent produces a hallucination, the audit trail can pinpoint the root cause, which is key to debugging these non-deterministic systems.
We established that infrastructure agents must evolve slower than traditional software because of non-determinism. A change that improves 99% of cases could introduce a catastrophic edge case failure. How do you safely manage this evolution?
They need robust, staged deployment practices starting with progressive rollout. Updates are deployed in stages based on risk. You start with low-risk internal utility agents, then partner-facing agents, and finally, only after exhaustive validation to high-risk transactional agents.
And since the outputs are non-deterministic, you can't rely only on traditional unit testing.
Absolutely not. That's where canarying and containment come in. The platform runs the new version alongside the old stable version in parallel. A specialized auto-evaluator agent compares the outputs. If the deviation exceeds a predefined threshold, the rollout is automatically aborted without human intervention.
This new agentic infrastructure also introduces novel failure modes. Let's walk through the required infrastructure failure catalog and the containment strategies.
This catalog defines predictable failures and their mandated responses. Let's take orchestration deadlock. This is when agents get stuck waiting for each other or calling themselves recursively.
What's the signal?
The detection signal is loop detection triggers and response times exceeding 300% of the baseline. Containment is immediate session termination, enforcing a maximum reasoning depth to prevent loops.
What about a policy misconfiguration failure?
The signal here is stark, a sudden global spike in blocked actions. The containment strategy is the immediate automated activation of safe mode. This mode requires mandatory human override for all autonomous actions, effectively bringing the system to a safe halt.
And if the security system itself fails, an identity service failure.
This shows up as a cascade of widespread 401 and 403 errors. Containment is rapid, reverting the entire platform to a strict read-only mode, blocking all write-back actions.
And the high-risk data integrity scenario, cross-domain leakage.
The signal is an anomaly in the audit plane. Agent B retrieves data from domain A without a valid contract. Containment is immediate. Isolation of the compromised agent, revocation of its identity token, and enforcement of the zero-trust data tethers.
Moving to observability and cost management. At enterprise scale, raw logs are useless. We need semantic telemetry.
Precisely. We need high-level vitals. One key metric is reasoning efficiency, which is the ratio of successful goals completed to the total token expenditure. This is the core metric for calculating ROI.
And the indicator of process friction, policy friction.
This is the percentage of agent intents blocked by the guardrails. A high friction score indicates either your business processes are clashing with safety policies or your agents are poorly prompted.
This new architecture also drives a fundamental economic shift away from CapEx toward reasoning OpEx operational expenses dominated by tokens and API costs.
Yeah.
How do organizations manage that?
Capacity planning becomes paramount. Mission-critical agents are given reserved capacity with guaranteed low latency. Non-critical agents use spot capacity, which is cheaper but can be throttled.
And how do we ensure fairness and accurate budget tracking?
We use fair usage enforcement with things like the token bucket model to prevent the noisy neighbor problem. And the system must enable automated cost allocation, or showbacks. If a sales agent calls a finance agent's tool, the platform automatically allocates the cost of that reasoning cycle to the sales budget.
This massive architectural shift can only succeed if the new operating model has clearly defined human roles. The structure of accountability must be crystal clear. Let's look at the key roles that must be established.
So first we have the Agentic platform owner. This person is accountable for the stability, security, and scalability of the shared substrate itself. They own the infrastructure SLA.
Then there is the functional counterpart, the domain product owner.
They own the goals, the business outcomes, and the ROI for the agents within their specific domain-like underwriting or customer service. They're judged on the business metrics the agent delivers.
The guardrails need dedicated oversight, which is the role of the policy steward.
Yes, the policy steward is a critical cross-functional role, staffed by members of legal, compliance, and security. They define the global guardrails as code and assign agents to governance zones based on their risk level.
And finally, the person with ultimate authority in a crisis, the incident commander.
This is the technical leader with the pre-delegated authority to trigger the global pause across the entire substrate during a systemic failure. They hold the keys to the enterprise's emergency stop button.
To structure decision-making, governance must be formalized using zoned governance, which defines where an agent can act autonomously versus where a human must intervene. What are those three zones?
We start with Zone 1. Critical. This includes actions with the highest financial or regulatory risk. The rule is strictly, agent proposes, human approves. No autonomous execution.
Zone 2, standard.
Here, the risk is medium. The agent acts autonomously, but only within small, predefined limits like processing a small $50 refund. Any deviation automatically escalates to a human.
And Zone 3, fully autonomous.
This is for low-risk, high-volume tasks. Think internal data summarization. The agent acts completely independently, and humans monitor outcomes asynchronously for quality assurance.
Okay, turning to the long-term plan. This transformation isn't a single switch. It's a phased implementation roadmap. What are the foundational activities for Phase 1?
Phase 1 is the foundational platform. The core activities are deploying the agent runtime and action gateway and defining the initial global safety guardrails. The signal of success is the first agent deployed with complete end-to-end auditability.
Once that foundation is stable, you move into Phase 2, shared agents and tooling.
Yes, you launch the agent registry and encourage teams to publish the first reusable utility agents. The success signal here must be measurable, hitting a target where 20% of new projects leverage at least one shared component.
Phase 3 introduces the most complex piece, cross-domain orchestration.
This is where you deploy the supervisor orchestrator from Layer 2 and enable the first true multi-agent collaborations. Success is measured purely on process efficiency, a 30% or greater reduction in cycle time for those newly automated processes.
And the final state, Phase 4, enterprise-wide optimization.
This involves implementing sophisticated features like self-healing infrastructure and dynamic priority queuing. The ultimate success signal is financial. The cost of reasoning must be demonstrably decoupled from business growth.
Finally, let's summarize all this with the production readiness checklist. Before any agent goes live, what are the non-negotiable checks?
This is the mandatory gate. It includes confirming the agent is defined by a versioned capability manifest in the registry, verification that all global guardrails are active and non-bypassable, ensuring human-in-the-loop thresholds are technically enforced, and finally, confirming semantic tracing is active and all kill switch procedures have been tested.
If that list isn't checked,
The agent doesn't deploy. Period.
what an incredible, granular breakdown. This is about moving AI from the experimental lab into the core operating model of a global business. The core transformation we've discussed today is really the end of the experimental era of AI and the necessary non-negotiable move to a substrate-first architecture.
So what does this all mean for you? The ultimate goal isn't just basic automation. It's turning autonomous reasoning into a sustainable competitive advantage. And that edge is only achievable if the intelligent workforce is architecturally robust, comprehensively governed, and infinitely scalable, operating on that shared substrate we've outlined.
If we look ahead, the integration of these agents transforms the traditional software development lifecycle into what we are calling a continuous reasoning cycle. Think about the power this unlocks. How quickly will your organization be able to evolve its core business processes when you can update an agent's reasoning logic, its capabilities, or its safety constraints daily, rather than waiting for months-long, tightly coupled application releases? That shift in organizational agility enabled by this architecture is something for you to mull or explore on your own. Thank you for joining us for this deep dive into the architecture of agency. We'll see you next time.